So in the previous example, right, we said that we can choose how we want to construct the hypothesis test depending upon what it is that we actually like to prove, right? Because hypothesis test is really just a tool. Now, we're pretty flexible most of the time, except that when the test involves something with very severe consequences, there is one rule that we need to follow. Now, this is not a mathematical rule. This is an ethical rule. So probably with social science, not going to apply that much, but this rule is really important when we're dealing with, let's say, in medicine. Or health research, etc. And that rule is the most serious consequence of a mistake or mistaken decision needs to be associated with the type 1 error. Okay, that's a little bit difficult to understand what that means. Okay, let me tell you the reason why first. Right? Why must we follow this rule? Because we can choose the type 1 error. We can choose alpha. Right? And type 1 alpha is the significance level that we choose for every test. Okay, let me do an example, and I think we'll see. I think you can see what does this rule mean. So suppose I need to test a blood pressure medication that is not yet approved by the FDA. How would I construct, or how would you construct this hypothesis test? All right. So let's say K. K is the minimum blood pressure. Okay. Right? So here's a blood pressure medication and say that it lowers your blood pressure. Now, lowering blood pressure is good. However, if the medicine lowers your blood pressure below K, then it might kill you. So it is dangerous. Now, what we want to know is, does this blood pressure medication, does it lower people's blood pressure below K? So I have two ways I can construct a hypothesis test. I can say, well, the null hypothesis here would be that mu is greater than or equal to k. So therefore, the alternative is that the mu is less than k. And here I have the null hypothesis, mu is less than or equal to k. And then the alternative hypothesis, right, is mu is greater than k. Okay, now which one do we choose? Now, if this is not a serious matter, such as such as blood pressure medication, then depending on what your goal is, you're free to choose either A or B. But this seems like a serious issue, blood pressure medication, so we need to follow this rule. Now, how do we decide using the rule? Well, first, let's think about what happens if null is rejected. So if null is rejected, right? What happens if null is rejected? Well, in this case, if null is rejected, then we support the alternative, meaning that the blood pressure medication will drop the blood pressure below K. So the drug is not safe. Right? Drug is not safe, therefore is not approved. Right? However, in this case, what if the null is rejected? If the null is rejected, then we are saying the blood pressure is not below K, in fact, it's greater than K, and therefore the drug is safe, or the drug is approved. Okay, all right. Now, drug is approved. Okay, now, but here's what happened. What happened, or is what we say is what is the consequence if in fact the null is false? Oh, sorry, if the null is true, right? What happens if this is a mistake? What is the consequence if we reject if this rejection was a mistake? Okay, so let me write down the consequence. So the consequence of error, right? What's the consequence of error? Well, I said the drug is not safe, but in fact is actually safe. So the consequence of error is, well, money lost. All right. All right. So probably the drug company lost money because the drug is actually safe, but then it was not approved. Money is lost. However, what if this is a mistake? What if we approve a drug because we think it's safe, but then it actually is not safe, right? So then, well, people people might die. Right? So I think subjectively, or even maybe objectively, we can say that this is a much more severe consequence. Therefore, right, we in a situation such as a blood, such as the medication trials, we're only allowed to use this type of hypothesis because now, right, I can choose alpha. That's the amount of risk I'm willing to take, right, to accept or sorry to reject the null hypothesis. And the smaller the alpha that I choose, right, the less likely I am to reject. I can choose a very small alpha. That if I want to be very careful, I can choose a very small alpha, and so there. So that makes it very unlikely to reject the null hypothesis. In another word, right, if I choose a very small alpha, then I will need a very strong evidence to reject the null hypothesis, right? So that way I can be sure, or at least I can try to be as careful as possible not to approve a drug that is actually that is actually harmful. Okay, take a minute to go ahead and read this problem. Right? You don't actually need the sample measures. This is a little bit too much information. All we want to talk about is the hypothesis test and which one do we choose. So I really have two hypothesis tests here, right? That I can construct. The first one is mu is greater than or equal to 100, and then alternative mu is less than 100. Okay, here mu is less than or equal to 100, and the alternative is mu is greater than 100, right? So if the radiation exposure is higher than 800 milligrams, then it will be really harmful. It is not safe. Okay, so we'll just take a minute, maybe pause the video if you want to think about which one then should we choose, right? So again, you think about what is the outcome if we reject the null hypothesis, and what is the consequence if that was a mistake. Okay. So if the null is rejected, that means this radiation is small, right? So that means that this is safe. This is safe to return. Now, if this null is rejected, then we support the alternative, and this tells us the radiation is too high, so it's not safe. So we stay out of Fukushima. Okay, but then what happens? Think about what happens if we made a mistake in rejecting the null hypothesis. Right? If this was a mistake, meaning that it was actually not safe, but we made a mistake and said that it's safe. It is safe to return. What happened? Well, radiation. Right? Kids might get cancer. Now, in this case, what does a mistake mean? A mistake would mean that it is actually safe, but we have but because the evidence we say that it is not safe. So the consequence, well, what is the consequence? Well, the return to Fukushima is delayed. Oops. Oh, sorry. YED. Return to Fukushima is delayed. Now there could be financial consequences of that, but I think one can argue that radiant over exposure to radiation to children, it's going to be a worse consequence than delaying the return to Fukushima. And because this and again, if we agree that this is the far more severe consequence, then this will be the hypothesis test that we want to use. Because again, we can choose alpha, right? We can choose alpha to be really small. That way we take minimum risk. We take so we can choose a small alpha. So that way we can take minimum risk as possible, right? And if I have a really small alpha, then I will need a very strong evidence to reject the null hypothesis, right? The smaller the alpha is, the harder it is to reject the null hypothesis.